In this video, we are going to go over how to solve two-step inequalities that might just involve having to switch the inequality sign direction. Let's jump right into them. So we've got the instructions to solve and graph each. So we're told negative 7y plus 6 is greater than 34. So how do we deal with that? Well, we are going to solve this like any normal two-step equation, undoing the order of operations, but being mindful of the fact that we might need to switch inequality signs using the rule that if you multiply or divide both sides of an inequality by a negative number, then we got to switch the signs. So first things first, we have to undo addition of 6. So we'll subtract 6 from both sides. Here we go. Minus 6 from both sides of the inequality. You're left with the 6's cancel. 34 minus 6 is going to be 28. So we'll get negative 7y is greater than 28. Okay, so now we take a look at what we have left and, oh, there should be an alarm going off in your head, right? Saying, I'm going to divide by negative 7 to undo multiplication by negative 7. And that alarm going off in your head is like, whoa, I'm dividing by a negative. So immediately switch those signs. That inequality sign switches. And if you're thinking, well, why does that work? Or how do we come about that? I have earlier videos on that where you can check it out. So definitely, if you're thinking that, check out those earlier one-step inequality videos. So negative 7 divided by negative 7 divides out. We've already switched the sign, so we're good there. Y is less than 28 divided by negative 7 is negative 4. And that's it. That's your inequality, which means that all numbers less than negative 4 will make this inequality true. So if you plug in a number less than negative 4, like negative 10, and we put that into this inequality, we will get a true statement. Let's check it out. So negative 10 is definitely to the left of negative 4. Negative 10 times negative 7 is 70, plus the 6 is 76, which is indeed more than 34. Very cool. So there's many, many solutions there. How do we show those solutions? We can graph them as instructed. So we've got negative 4 as our boundary. And we have less than, which means we're not going to include negative 4. We'll have an open circle. And then less than means all numbers below negative 4, which is all numbers this way. Beautiful. All those answers, tons of them, infinitely many of them, going to give you true statements when you plug them into the inequality. All right, last but definitely not least, we've got this problem where it looks like we're going to have to distribute to start because, well, a number times a quantity is begging for us to distribute. So let's tackle that first. I'm going to multiply by negative 3 to each term. Negative 3 times 6 is negative 18. Negative 3 times a positive 5a is negative 15a, or minus 15a. And I'm just copying the inequality sign as less than or equal to 15. From here, we've got a two-step inequality. To solve it similar to what we did in the last problem, I'm going to undo minus 18 by adding 18. Some people get a little squirrely, a little weirded out by the fact that the number's first. No worries, you're just undoing the minus 18, and what you do to one side, you must do to the other. So I add 18 to both sides, and we get this zeroes out, and we're left with minus 15a is less than or equal to 15 plus 18 is 33. So we get a positive 33, and then from here, I'm going to undo multiplication by negative 15. So I'm going to divide by negative 15, and again, whistles, bells, something should be going off in your head being like, yo, you just divided by a negative number. With an inequality, flip those signs, right? Automatically, just get that done. The negative 15s divide out. You're left with a is greater than or equal to 33 over negative 15. And I am going to simplify that. The greatest common factor of 33 and 15 is going to be 3. So I'll divide the numerator and the denominator by 3, and that will give you that a is greater than or equal to 11 over negative 5, or negative 11 fifths. So negative 11 fifths is 2 and 1/5, or negative 2 and 1/5. So we're going to graph this out. Let's do it. I'm going to have to duck down to do that here. So negative 11 fifths, let's say we've got the numbers 0, 1, so it'd be negative 1, negative 2, so we're just going a little bit beyond negative 2 here. It's or equal to, so we're going to include it. And then I need to shade all the numbers to the right of negative 11 fifths. Ooh. Just like that. It's a beautiful thing. All right, so hopefully at that point you're looking at this saying, I got this. I understand that solving two-step inequalities is about treating them like equations, but being aware that if you multiply or divide by a negative number, switch those signs. Now go practice some problems.